Good morning, everybody. Hi. In this session, we will discuss about various FPGA, classification of FPGA, and what are the various logic cells or internal architecture of FPGA that we will discuss throughout this video. Friends, before going to the implementation part or FPGA implementation part of any digital logic, what are the various flow or design VLSI design flow exists, and how to achieve realization of hardware for a particular digital design, what are the classification of VLSI design flows that are existing in the market, that we will discuss in this duration of our video clip. Okay, so now I'll start with the chip design methods. There are two ways in which we can develop the chips. One is ASIC design flow and another one is FPGA design flow. Here, ASIC design flow consists of application specific integrated circuit, and FPGA, which are these integrated chips or ICs which are used for only specific application, and FPGAs otherwise another classification is FPGA, field programmable gate arrays, where different digital designs can be implemented by using these FPGA blocks. Here, although the ASIC can be quite efficient in terms of design area, power and speed, these in a digital system design, all in order to achieve the overall performance of the IC, here three factors we have to consider. The performance factors are design area, which should be low enough, and low power consumption, and with the high speed performance is required, because high computation capability of the chip with a low speed, lowest time, low delay, the overall delay of the chip must be low enough to achieve the highest performance in terms of speed. So that can be very exhaustive in terms of time consumption and resources. Here, the long time ASIC will take long time to manufacture a customized chip from scratch, as well as it will require high investment also. So the initial cost of investment in terms of silicon fab or fab labs is very high enough. So therefore, as long as the desired product is not needed in bulk amounts, then we have to go to FPGA is a better adequate choice rather than ASIC choice. Now, considering these chip design methods into account, a VLSI design flow is consists of various steps called specification, architecture, RTL coding, representation in terms of verification, and then synthesization, backend, and then synthesis will goes to backend, tape out, and foundry. Here, the specification, architecture, RTL coding, and RTL verification, all these steps comes under front end design part, whereas the synthesis and synthesis, up to the synthesis we are considering it is a front end, and whereas the synthesizer design is given to the back end, which is in turn called as a physical design implementation, where the placement, routing, mapping, and interconnects, all these internal tasks will be performed at the back end layout, and then these layout will be taped out into IC after testing, suitable testing, and verification part. So after the finally tested chip will be given to the foundry for the fabrication of a 3D IC. Okay, so here all the design related activities are represented in terms of light gray color, and non-design related activities is represented by means of a dark gray color. That is foundry part. Now, this is a VLSI design flow, where the chip design methodology has to be undergo right from specification to the foundry scale. Here, what are the design specifications? Now individually we will discuss about the specification part. The specification of an IC that we have to design, or we have to implement, or up to the foundry that we have to send the design is in terms of will be represented by means of an RTL, or by means of a hardware description language. These hardware description languages are many other categories are there. In this hardware description language, one is Vhdl and another is Verilog, system Verilog, and successively UVM for verification, and test bench is used for testing purpose. So the HDL, in our syllabus we are having Vhdl part, and we will discuss what are how to represent a digital system by using the Vhdl language. So here the design flow of an ASIC is divided into various blocks, right from the fundamental digital design specs to implementation. So the digital design specification consists of just now we have discussed all the performance parameters of an IC, where at the end product has to meet. The end product is nothing but an IC which we are designing. Okay, so here the end product sometimes it may have low power consumption, or some ICs may have high speed performance. Some ICs may achieve has to be designed with a low area consumption. Okay, so occupancy of the low area of within the silicon chip substrate. Here the design specifications in terms of power, area, and speed performance factors, and that also internally it may have sometimes it may has to achieve lowest rise time, fall time, and timing constraints has to be met. So these are the specifications that we have to consider for a particular IC. Now the IC after the design specs of an user, that a digital engineer, design engineer, or RTL engineer will consider all these specs into account, and he will describe the fundamental concept or fundamental behavior of the circuit, or in terms of its functionality will be described. So that particular description can be represented as RTL description, registered transistor transfer level logic description. So this particular description is mentioned by using any one of the hardware description language. Just now we have discussed, like either by using Vhdl or by using Verilog, we can write the coding. So this HDL level representation of RTL is given to the next step, functional verification and testing. This particular step I am calling it as also RTL simulation, or just like that circuit simulation. The circuit simulation can be done where the functionality of the circuit or system or the architecture will be, which we have written in a HDL, will be tested with prior or suitable inputs. What we are calling in the digital system design, those inputs are called input. The relation between inputs and outputs will be checked at this particular level. So the relation between input and output of a digital circuit or system is called as simulation. So simulation. Now by applying various stimulus, here we will check the simulation results for the digital design which we have implemented. So the simulation, after the simulation, logical synthesis has to be performed. Here other than logical synthesis will be performed, where timing related verification of design will be handled at this particular stage. Okay, so and at this particular stage, after the logical synthesis, each and every level hardware description, RTL description of code is converted into RTL into gate level netlist. So gate level netlist means the circuit will be represented in terms of logical gates, Okay, so after this synthesis it will generate the gate level net list. The tool itself will generate and it will convert RTL to gate level at this particular level. So by doing the synthesis part only, after the synthesization of the circuit, RTL level will be converted into gate level netlist. So here with this particular step, logical verification and testing will be performed. After that, the design will be given to the back-end stage. Back-end mean after that the placement part, floor planning, automatic routing, placement, routing and interconnects will be performed. After that interconnections, placement and routing, here the best placement and optimization, here the layout will be generated and the physical layout is given to the verification again, and if any errors, again it will go back and do the necessary steps to modify floor planning, or either by modification the placement of the blocks, or either by doing the modification the routing protocols or routing and interconnects, we will achieve the necessary physical layout implementation and verification will be performed. Okay, so here that everything, once the layout verification is also over, then the next step will goes to hardware realization. Hardware realization can be done by by giving the design or by dumping the design into FPGA, field programmable gate arrays, or we can connect a CPLD like complex programmable logic devices, or we can give the implementation part to either basic PLA or PIL hardware logics. So now previously just a microcontroller can also be used to realize the code whichever we have written, and whichever it is tested can be given to this implementation level to verify the real-time implementation or real-time checks for the suitable stimuli. So that particular part of dumping the code into hardware realization is called configuration. What we are saying, we are calling it as a configuration of the FPGA. So after doing the configuration of the FPGA, the code will be dumped into the FPGA in terms of bit field or bit field generation. That bit field code will be bitfield code will be generated or transferred into the FPGA, so that the code will be dumped into the FPGA and final realization can be performed. So this is the design flow of an ASIC, and the bitstream file generation at observe the FPGA design flow consists of design source file, synthesis, behavioral simulation, synthesis and design implementation. These are the 4 blocks. Here the behavioral simulation will be checked at the simulation level, and functional verification and timing generation reports will be generated at after the synthesis, and then after the implementation part, here static timing analysis and back annotation like bitstream file generation will be performed. Uploading the FPGA into board and in-circuit verification. Here the design implementation part consists of internally translation, mapping and then placement and routing part. So here design implementation internally, after doing the perfect translation of the code into gate level netlist, and then mapping of into suitable configurable logic blocks, and then placement and routing of the logic onto the FPGA board. Here after performing all these 3 steps, a bit file will be generated. So the tool itself will generate the bit file. This bit file will be uploaded or dumped into the FPGA. The process of dumping the code into FPGA is called configuration of the FPGA, configuring the FPGA or programming the FPGA. So this after programming the FPGA, the in-circuit verification of the logic will be performed. So here the in-circuit logic will be performed. So with this, in this particular module we have discussed what are the various design flow methods exist, and What are the various stages of VLSI design flow, FPGA design flow, and ASIC flow we have discussed in this particular module. Thank you. Good morning. Good morning. Hello. ఏం చేస్తున్నావు? గుడ్ మార్నింగ్. ఏం చేస్తున్నావు? నేనా ఇప్పుడే ఇంట్లో ఉన్నాను. వీడియో లెక్చర్స్ చేద్దామని కంప్యూటర్ ఆన్ చేస్తున్నా. అసలు చేయలేదు, ఏమి చదువు సందలేదు 3 రోజుల నుంచి. గుడ్ మార్నింగ్. ఏమి లేదే, తిరగడమే పని. అటు ఇటు ఇంట్లో పనులు, బయటకు వెళ్ళడం, అవి చేయడం, ఇవి చేయడం, అంతే అయిపోయింది. ఈ స్విచ్చెస్ కాదు, ఒకటి స్టార్ట్ పెట్టాము, 2 ఏం పెట్టాము? కాజ్ 3 4 స్టాప్. రికార్డ్ అయిందో లేదో తెలీదు, ఒక పావుగంట నుంచి వాగుతుందా, అదే చూస్తున్నా. గుడ్ మార్నింగ్. అది చూడాలి, పోతుంది. ఇదే ఫస్ట్ 2 యూనిట్లు చేసి పెట్టేద్దామని. రేపు టికెట్ ఇంకా చేసుకోవాలా, చూస్తా. జంషాబాద్ రేపు ఈ టైంకి ఉంటుంది ట్రైన్, కరెక్ట్గా 3:20 ఉంటుంది మధ్యాహ్నం. 3:20 అంటే నేను 2:30 అలా రావాలి, తినేసి బయలుదేరుతా. అప్పుడు రాత్రికి అక్కడ ఉంటే పొద్దున్న పడుకొని లేవచ్చు కదా అని ప్లాన్. తెల్లవారుజామున కష్టం అయిపోద్ది. అదే ఏమి ఎంజాయ్ చేస్తున్నావు బాబు? గుడ్ మార్నింగ్. నిన్న జబీనా ఫోన్ చేసింది, చిల్లీ చికెన్ ఎట్లా చేయాలో చెప్పండి అని చెప్పాను. చేసుకుంది అనుకుంటా, తెలియదు మళ్ళీ ఎట్లా వచ్చిందో అది. మళ్ళీ గుడ్ మార్నింగ్. తను చేసిందిలే. పేటెంట్ అన్నాను కదా, పేటెంట్ అంటే పేటెంటే చెప్తామేంటి? చెప్పండి మేడం అంటే నాకేంటి చెప్పు. క్రెడిటా? సరే, ఏమిలా నూనె మరిగాక కొంచెం అజినమోటో టేస్టింగ్ సాల్ట్ అని ఉంటుంది కదా, అజినమోటో చిటికెడేసాం అంతే. కాదు, నూనె మరిగిస్తామా ఫస్ట్, ఆ 2 స్పూన్లు నూనెలో అజినమోటో వేస్తాము. ఏం వేయకముందు నూనె మరిగాక ఈ అజినమోటో వేస్తాం. అప్పుడు ఏంటంటే 1 స్పూన్తోనే నీకు చికెన్ అయిపోద్ది. 1 స్పూన్ నూనెతో, నూనె పీల్చదు అసలు. 2 స్పూన్తో అయిపోద్ది. ప్లస్ కొంచెం ఏంటంటే ఈ ఫుడ్ కలర్ వేయలేదు, వేస్తే ఇంకా బాగుంటుంది. నూనె మరిగాక గ్రీన్ చిల్లీస్ వేసాను, కరివేపాకు వేసాను, క్యాషు వేయాలి, అవన్నీ వేపి పక్కన పెట్టుకోవాలి. పక్కన పెట్టుకుని తీసేసాక ఆ నూనె దానిలో ఈ చికెన్ ఆ నీళ్ళతో పాటు వేసేసాము అలా. ఫస్ట్ ఆయిల్ పెట్టానా, ఆయిల్ పెట్టి ఫస్ట్ చేసింది అజినమోటో తీయం, అందులో వేసి వేపుతాం అనమాట. అది కొంచెం చిటికెడ వేస్తాం అంతే. వేసి బయటకు తీసాం. ఆంటీ ఇల్లు తుడుచుకుంటుంది. అదే నుంచి చెప్పా అవన్నీ.
మిరియాల పొడి 2 స్పూన్లు,
పెప్పర్. గుడ్ మార్నింగ్.
ఫస్ట్ ఇంకేకర్లా ఫస్ట్ వేసి పెప్పర్ సాల్ట్ పెప్పర్ కలిపేయండి. ఉప్పు కారం కలిపినట్టుగా కడిగిన దాంట్లో అది 3 కూతలు 2 కూతలు వేయించేయండి. 2 కానీ 3 కానీ
5-6 వేసాం.
5-6 అంటే ముదుకూర అయితే వేసుకోవాలి. 5-6 మామూలుగా కుక్కర్లో పెట్టేసేయండి. 3 కూతలు వేసేస్తే చాలు. 3 అది చల్లారిన తర్వాత కళాయి పెట్టి వాడి పెప్పర్ అది వేయండి. అజినమోటో వేయండి. ఆయిల్ నూనె వేడెక్కాక వేయండి అజినమోటో. ఎంత ఊరికి 2 వేళతో తీసేయండి. కరేపాకు గ్రీన్ చిల్లీ వేసి అందులో వేసి తీసి పిల్ల పెట్టుకోండి. ఒక బౌల్లో బయట తీసేయండి. అది క్యాజు కూడా వేపేసి ద్వారగా ఇంకా బయట తీసేసుకోండి. అన్ని బయట పక్కన పెట్టేసుకుని ఆ ఆయిల్లో ఈ కూర దిమ్మరిచ్చేయండి చల్లారిన తర్వాత. ఇప్పుడు మూత తీయాలి, చల్లారి మూత తీయాలి.